Let's talk about edge awareness, edge comfort with waved lens designs. And I want to put some perspective on this. This is just the default lens. It's not the lens, but it's a place to start. And we've become accustomed to expecting to see this kind of look with our lens designs. But let's look at other sources. I'll minimize this. Within the Scout software itself, there is a contact lens module. It looks like a little contact lens. And I'm going to let the Keratron, the Scout software, design a custom lens. Let's see what they came up with. Now, if you look at this tier layer graph that they have displayed below and the fluorescein simulation above, you'll notice that the tier layer thickness out here at the edge is over 100 microns on both sides all the way around. It's about 100 microns, and this is only an 8.5 millimeter lens. Maybe there's something funny about this software. But anyway, that's what the Keratron, the people from Europe, I think they're probably pretty experienced and intelligent. Anyway, that's the way they came up with the edge, was to have almost 100 microns tier clearance. Another resource we can look at from the internet, this is tier layer graphs from competing software companies, two different companies. And if you notice their tier layer graph, their tier layer thickness at the edge is 75. Maybe a little tighter than a conventional lens, but still quite a bit. If we then go to Wave and look at what we've got here, we can say, well, by golly, we've only got 10 microns here. Let's make that about 75 or 100, something really big. Might even have to change the scale because it only goes to 70. So I'll keep going up with it. And let's see, now we've got a tier layer of 80. Oh, let's give it a couple more bumps, so we're kind of midway in there. And we can see that the rest of our lens is fine. All we've really done is lift the edge quite a bit. And so now we have a very similar look to what we see with some of the other notions out there as far as what makes a comfortable lens. I think this might be part of what some people are noticing with comfort problems on conventional lenses. When you're fitting a conventional GP lens, you might ought to use a really high edge lift, something like 73 or something. And when you look at this in back axial mode, you'll notice that it's very blue out here because the curvature out here is almost 11. So this is about the same as taking an 11 millimeter tool and putting a couple of tenths width of an 12 millimeter tool out here on the periphery. That's basically what we've got here. They have a peripheral curve of 12 to create this, and we're not quite as high as they were, so we're more like around 10, 10 and a half, 11. But this is the kind of design that is conventional. It's the typical approach to trying to make the patient so that they're unaware of the lens. Now, I'd like to say that I don't really think this is great for Ortho-K. Typically with Ortho-K, you need a pretty low edge lift. It just works a lot better. But for conventional design, this might be what you should do in your wave design to address edge awareness. I think when we're this far away from the cornea, the detail of the edge becomes less significant.